Hello everyone, welcome to our discussion of the surface analysis chart. The surface analysis chart is an analysis of observations that, of course, are made at the surface. And there are all sorts of things that make observations at the surface, things like, well, ASOS and AWOS stations, but then also it includes things out in the middle of the ocean or in the Gulf of Mexico, such as buoys, and also ships. They make observations. So there are many things that are on this chart. You'll see analysis and also plot of sea level pressure. They analyze pressure patterns such as troughs and ridges, highs and lows. Also they put fronts on here, and then other symbols as needed. The altitude of this chart, of course, is the surface, but the surface of the Earth varies as you travel across the United States. So the altitude varies. And as a result, the pressure that's measured at the surface of the Earth also varies. So they correct for that, and we'll talk about that later. So a lot of different organizations put this chart out. We're most familiar with the Weather Prediction Center. Those are the people that are doing that chart for the 48 contiguous United States. But the other organizations, such as the Alaskan Aviation Weather Unit or the WFO in Honolulu, will put out specific charts for their areas. The chart comes out every 3 hours. You don't need to memorize the issuance time, but the chart is issued at 0, 3, 6, 9, yada, yada, yada. They have a projection for CONUS, in other words, the continental United States, and also they have a projection for North America. Of course, the chart is made of observations and analyses. The observations are station models. We're going to look at the station models right now. Station model is a depiction of information in both textual and graphical form. We'll start out with temperature and dew point. Those two numbers are plotted in Fahrenheit as reported by the METAR or by the station, by the ASOS or the buoy. Next comes sea level pressure, and sea level pressure is defined as the atmospheric pressure at mean sea level, either measured directly or typically calculated or empirically derived from the observed station pressure. What that means is that at the surface of the Earth, pressure varies with altitude, of course, as the elevation changes. So you actually have to calculate the sea level pressure. I think most of you are familiar with that concept already. This is what they do. Station pressure is measured at a station. That's the actual pressure. For example, if the station was about 5,000 feet, like Denver, Colorado, then the pressure measured would be about 850 millibars. If that was put on the surface chart, then there would be a permanent low pressure system in mountainous areas. So we try and bring it down to a standard level, which is sea level. So all pressure is reduced to sea level. And they use empirical relations to calculate that. Typically, pressures are close to about 1,000 millibars or 1,000 hectopascals. So this is how it's represented on the station model. They put a number, sea level pressure, 3 numbers, and you need to either add a 10 or a 9 to the beginning and a decimal point in front of the last number to get it closest to 1,000. And so sea level pressure is reported to the nearest tenth of a millibar or hectopascal. Next comes the weather. They use symbols to represent the weather. You are probably familiar with a lot of these symbols, and here they are. And there's a lot of them. And you don't have to memorize all of these, but you'll have to memorize a good number of them. Here are the ones that you need to be familiar with. I will plot these or put these out at EasyLMS as a separate PowerPoint so that you can study from these. But the number of symbols determine the intensity of precipitation. That's very important. Also, there are other symbols that are used for freezing rain and freezing drizzle. Notice that it's either a dot or a comma. And then also you need to be familiar with the symbols for showers and also ice pellets. And then thunderstorms look kind of funky. They put the type of precipitation on top. If it's just lightning by itself within 5 miles of the airport, then they will indicate it as just lightning visible without any precipitation. Also, they will plot obstruction division. There are many different kinds. You guys are probably familiar with the difference between fog and mist. Of course, fog visibility is lower, 5/8 or less. Smoke, drifting snow, or blowing snow. Freezing fog is fog that occurs at temperatures colder than 0 degrees Celsius. So that's plotted in the weather section. Also, they put the sky condition or the sky cover, and they use the octas to represent that. You're probably familiar with clear, few, scattered, broken, or overcast, and then of course obscured. It depends upon the number of eighths of the sky covered with clouds. The wind is also plotted. Most of you are probably familiar with this. They use wind barbs to tell you which direction the wind is coming from. And then they use pendants or little flags to indicate the strength. A calm wind is indicated with a circle around the station. And then another thing they put on here is the pressure tendency, or how the pressure is changing over the past 3 hours. And they do it in terms of tenths of millibars. So you put a decimal point in front of the number. There might be 2 numbers if the pressure is changing very rapidly. And they use symbols to represent if it's going up or down. So here's various examples of station models that you can practice with. And they are difficult to read on the original or the black and white surface analysis chart. On the left you can see blowing snow and snow. On the right you can see a thunderstorm with heavy rain. Here are examples. On the left you can see a station model representing a freezing fog, and on the right you see a station model that's showing precipitation, and it looks like that's snow because the temperature is colder than 32 degrees Fahrenheit. So we're done with observations looking at the station model. Now we'll talk about analyses. And there are 2 different types of analyses that are plotted on this chart: a frontal analysis and an isobaric analysis. The frontal analysis includes all sorts of different boundaries at the surface of the Earth. It includes your basic fronts, such as cold fronts, warm fronts, stationary fronts, and occluded fronts. Also, it includes whether the fronts are being born or dying. That's what we call frontogenesis, the birth of a front, or frontalysis, the death of a front. Don't worry about those symbols. You won't need those symbols on the exam. But you do need to know the other boundaries, such as squall lines, and also dry lines, and troughs, and ridges. So here is a surface analysis chart, and we have different frontal analyses on this one. You can see the dry line across Kansas, Oklahoma, and West Texas. There's a stationary front that extends from Nebraska through Missouri into Illinois, and then all the way back into Colorado. And then actually that stationary front keeps going through New Mexico and into Arizona. Here's an example of a squall line that's going through East Texas. And also you can see a low pressure system kind of over Fort Sill area of Oklahoma. And you can also see a trough of low pressure stretching across the central part of Texas. Here is many troughs. You got a trough across North Dakota from near Bismarck all the way across Williston. There's another trough across South Dakota from somewhere near Rapid City up to about Watertown. And then you've got warm fronts and stationary fronts and cold fronts and all sorts of other things on this picture. So not only do you have frontal analyses, but also you have an isobaric analysis. In other words, they draw lines of constant pressure, which we call isobars, and basically they give us an idea of the pressure pattern at the surface. Now this is sea level pressure. What they do is they look for areas of maximum and minimum pressure. Areas of maximum pressure are given the letter H for highs, and low pressure systems, minimum areas of minimum pressure. Troughs and ridges are extensions of relatively lower pressure, or ridges are extensions of relatively higher pressure. Usually you don't see ridges drawn on the surface chart very often, but troughs are drawn. And the reason for that is because troughs typically result in bad weather or at least a wind shift. So using the surface analysis chart gives you a big picture. I mean, you're looking from coast to coast, north to south, seeing what's going on. You can use it to look for pressure systems, figure out where there's a low or high, and then also the location of fronts. And you can use the chart with the isobars to figure out where the winds are, which way they're going. And then also you can measure, or you could read right off the chart the temperatures and dew points for areas of moisture. So as I said, isobars give you an indication of which way the wind is blowing. Remember, the wind blows counterclockwise around a low and clockwise around a high. It blows in towards the low across the isobars because of friction. And the closer the isobars together, the stronger the wind speed generally is, and the more intense the weather system is. And of course, remember that fronts also indicate a change in temperature and a change in wind direction, and also possibly weather. You can go out to the Weather Prediction Center. This is where they make the surface analysis chart, and they've got all sorts of different kinds. I'm going to just page through these real quick just to look at the different kinds of surface charts. So here's one that's very colorful. It shows you kind of terrain. Also gives you isobars and areas of highs and lows, and also is got a frontal analysis. Here's another example without the colorful ground. It's just black and white. Actually, the fronts are color, so that's nice. There's no station models on this, so you have to infer the winds just from the isobars. Here's one that you see quite frequently at the Aviation Weather Center, where they highlight the United States in white and all of the fronts are in color. Also, they give you the highs and lows and also isobars. And then this is a North American projection. The one that you saw before was the CONUS projection. This is the North American projection looking at only North America. And then here is another CONUS projection with station models to help you figure out where the winds are blowing. They don't plot all the station models, just give you a representative sample to help you figure out which way the winds are going. And then you can zoom in at the Aviation, or not Aviation Weather Center, but the Weather Prediction Center. They have regional surface charts like this. And then finally, if you go to the Aviation Weather Center and go to Prague charts under forecasts, that takes you to this, and you can get a surface chart by clicking on surface. And the first one you see there is the surface analysis for the latest time period. That's all I got for surface charts, and I hope you enjoyed this video.